This is video number 2 for sections 8.6 and 8.7, Problems About Averages Part 2. This is just a continuation of the last video. Remember, we've got Roman making his boomerangs, and now finally we get to what Roman is really interested in, which is making a profit. He's selling these things, he wants to make some money, and we're assuming in this problem that he's decided if he can make a $4 profit on every boomerang, that would be pretty good. Well, here's our third and final function of this problem. We've got P of n now. P of n, P stands for the price he should use. In other words, the price tag. What's he going to write on the price tag in the stores? P is the price tag he should use to get that profit he wants when he produces and sells n boomerangs. So n still stands for how many boomerangs. P is the price tag he needs to use to get his profit. We are making the assumption here that he is going to sell out, that he's going to sell as many as he produces. Okay, once again, we're being asked to write an equation for this function. Well, this turns out to be very, very simple. Look at the hint. We already found a function earlier, the B of n function we called it, that represented the break-even price, the price tag he should write down to break even. Well, all you got to do is take that price tag and raise it by $4. Then he'll be making a $4 profit on each boomerang. So this means my P of n function, my new price tag function, take that B of n function, it was 5n plus 2,000 divided by n. That was the break-even price. Just add $4 onto that, and you now have the final price tag. The directions do say to simplify this function. All we can really do is we could go ahead and add these two pieces together. So let's go ahead and do that. That's using some of our skills from Chapter 8. How do you add a whole number and a fraction? It's probably a good idea to put a 1 underneath the whole number. Then I need to get a common denominator. Really the only denominator we're talking about here is the n. So n would be my common denominator. I need to change each of these fractions so that the denominator is n. Of course, the first one is fine just the way it is. I can just copy that down. It's the second one where I'm going to have to do some multiplying. To go from 1 to n is going to require me to times this guy by n, and I can do that as long as I also times the top by n. So my new numerator here would be 4n. Now I have a common denominator, so I can go ahead and I can add these two fractions. The tops just add across, 5n plus 2,000 plus 4n. When you combine your like terms, you're going to get 9n plus 2,000. The bottom just stays the same, and I'm done. Here's my final version of the P of n function. Remember, P stands for the price tag, and n stands for the number of boomerangs. All right, let's go down to letter H. I believe now we're going to use this function we've just created. So letter H says find P of 500. That's as simple as just replacing those n's with 500. So let's do that. And we've got some math we need to work out. Looks like 4,500 plus 2,000 over 500. That makes 6,500 over 500, and if you grab a calculator, I believe you will discover that value to be 13. Okay, so P of 500 is equal to 13. Now we're supposed to write a little sentence for what we've just found here. Well, this is where you have to remember what your variables represent. N, which is the 500 in this problem, stands for how many boomerangs we're making and selling. So this month we've made and sold 500 boomerangs. P, remember, tells me the price tag I should use in the store if I want to make that $4 profit on each boomerang. So we're saying if he makes and sells 500 boomerangs, he's going to need to set his price tag at $13 each. That's that 13 we found, if he wants to get that $4 profit on each boomerang. All right. Let's go down to letter I and end this problem off. Letter I says, hey, Roman just thinks he can't charge $13. It's just too much. He figures the best he can do out in the stores is to charge $10.50. Well, he doesn't want to just drop that price. It'll cut into his profits. He wants to figure, okay, I'm going to have to make and sell more. I'm going to have to really crank things out and do a better job selling so that I can charge $10.50 but still get all the profit I want. That's the question here. How many does he need to make and sell to keep his profit if he's only going to charge $10.50? Well, I just need to go back to that P of n equation, right? P of n, this function is the one that tells me here's the price to use if you are making and selling n boomerangs. Well, we are being given a price of $10.50. I just need to set the price to $10.50 and then solve for n. Let's go ahead and set that up. All right, so here's the equation that we need to solve. It is once again a rational equation, which is why it fits into Chapter 8. I'm going to clear the fractions. Actually, the algebra is very similar to what we did the last time. I'm going to multiply both sides by n, which is the LCD. On this side, the n's cancel. I can then simplify the remaining equation, and then some simple algebra to finish it off. Subtract 9n from both sides, and it looks like we're going to have to grab a calculator and do some dividing. So we divide both sides by 1.5. It doesn't come out nice. Rounded to the nearest whole number, though, I get 1,333. And that's our answer to this problem. That's 1,333 boomerangs. We're basically saying to Roman, look, if you can only charge $10.50, but you still want to make that profit you want to make, you've got to crank up your production to where you are both making and selling 1,333 boomerangs each month.